Professor. This is Karan, and I'll be doing the second question of homework 5. Yes, so in second question, we have been given the density function of x and y as a upon y square x between the limits, that is y greater than 1, and x would be between 1 upon y and y. So first we are asked to draw a non-zero definition region of fx of y. Now for y greater than 1, it will be, that is this line, everything above y is equal to 1, y is equal to 1, that is everything above y is equal to 1. And for x, for value of x, that is the graph 1 of y is would be something like this, and the graph y would be this one. So value of x would be area between these two graphs. So we have the area, the non-zero definition area as area between these two graphs above 1. So this is what we have, the shaded area till infinity. Now the second question is, we need to find the value of a for a valid joint density function. Now for a valid joint density function, the integral from minus infinity to infinity of fx of y of fxy should be equal to 1. Now this can be read now. First we do an integral with respect to dx and then dy. For dx, the the limit would be 1 upon y to y, and that is if we take that is if we draw if we if we take a finite area, that is from draw a finite area, the area will it will be from 1 to 1 upon y to y. This will be the integral. So for x, and for y it will be from 1 to infinity. So when we take integral a with respect to x, a upon y square is constant, so we get ln of x for integral of 1 upon x as ln of x, and the limit would be y and y to 1 upon y. So we get the value as ln of y upon y a ln of y upon y square. Actually 2, because this can be rewritten as y minus y minus 1. So we can this will be plus ln of y, that will be 2 times ln of y. So 2a ln of y upon y square dy is equal to 1. Now we need to integrate this term with respect to y from 1 to infinity. Now we can rewrite ln of y as a. So we have a upon so the dy would be 1 upon dA would be 1 upon y dy. So it is dA, and 1 upon and y would be e raised to a. So we can rewrite 1 upon y as e raised to minus a. So we have integral from 0 to infinity of a raised to minus a into e raised to minus a from 0 to infinity is equal to 1. When we do an integration of this term with respect to, we use the multiplication, the partial multiplication of integration, property of integration. So we get value of so we get this integration of this term as a e raised to minus a minus integral of e minus a or dA. So this is not dw, sorry, should be dA, that is equal to 1. On solving further, we get 2a is equal to 1, so a as half. Now we need to find the marginal density functions. For the marginal density function of y, we have to we integrate the density function of xy with respect to x, and the limit would be from y to 1 upon y. For from y to yes from y to 1 upon y, for value of y greater than 1 going to infinity. So we have integration as ln of y upon y square, that is from 1 to infinity. Now for now for f of x, we need to integrate the fxy with respect to dy. Now the x has a value from 0 to from 0 to 1, and then from 0 to 1 as 1 upon y, and from 0 to 1 as 1 upon y, and from 1 after 1 it will be 1 to y. So basically for value of x from 1 sec something for value of x from 1 to infinity, it will be 1 sec. Oh yes, sorry, my bad. Yeah, yeah. So for 1 to that is from, if we take, it will be the, we'll have two values, that is from 0 to 1 we'll have to integrate with limit of 1 upon y, and from 1 to infinity, from we'll have to integrate with 0 to from infinity to y. So basically we have integration as 1 upon 2 for 1 to infinity, value of x from 1 to infinity. We have integration of fxy with respect to dy with limit from x to infinity. So on integrating we get 1 upon 2 x square. And for x of value of x between 0 and 1, we have integration as 1 upon x to infinity, that is half. So when we rewrite the density function as fx of half for 0 to 1, and half 1 upon 2 x square for 1 to infinity. So we can so the graph would be something like half, that is at 0 it will be half, and then half x square. And for fy it would be ln of y upon y square. The graph would be something like this. Now we have to check if the density function of fy and fx are valid. So to check that, we have to just see the integration from minus infinity to infinity comes to 1. So again, as done before, we'll have to integrate from ln of y, f of y from 1 to infinity, and on integrating we get the value as 1. And even for fx, on integrating from 0 to 1 for half, and 1 to infinity for half x, 1 upon 2 x square, we get value as 1. So both fx and fy are valid density functions. Thank you.